Yes, at least in theory. In fact, it's already been done before. Well, sort of. Theoretically, there's nothing stopping a Roblox version of Minecraft from being possible in the first place. Speed isn't an issue, as Roblox's LuaU runs much faster than Java from Minecraft Java Edition. Roblox also handles much of the physics and 3D graphics you'd otherwise have to make yourself. You could even fully implement multiplayer, if you cared enough to do so, that is. I'd argue that much of the reason a good one-to-one multiplayer clone doesn't exist is simply that no one's taken the time to do so, even if there is a lot of opportunity to monetize. One of the better ones I've seen is called CraftBlocks. Creative name, I know. And it was really cool to see, but you could definitely tell that some optimizations were lacking. While they may have been using some sort of culling, chunks seemed to be limited to a radius of about 2 or so, and every block was rendered individually, meaning that you could see the chunk being built from the ground up. It's just that there's a lot of opportunity for a good Minecraft clone to be made in Roblox, but the ones that exist right now just aren't very good and could benefit from a lot of improvement. So that's the mission I'll be taking on today. I want to make the best Minecraft clone, but within the Roblox game engine. The start of making the game actually went rather smoothly. Minecraft blocks are roughly 3x3 studs, so I made cubes in that form factor. I don't really know how precise that is, but it's close enough for now, and that can be accounted for if I do some sort of custom character model later. I then made a system to lay out chunks 16x16 in size, which has some variation into it. This, much like Minecraft, uses an algorithm called Perlin Noise. There's no textures yet or anything, but at least we have some sort of terrain generated. At the moment, the chunks don't load and unload as I move, which is a bummer as it removes the point in actually exploring, which is what Minecraft is arguably best known for. But it shouldn't be too hard to implement, and at least I have some sort of terrain to test other features on. As of now, I want to focus on placing and breaking blocks, and maybe I can start introducing a few real gameplay elements. There were a few ways I could have implemented the place logic for the blocks. I ultimately decided on just detecting what face was clicked and placing a block on the corresponding side. For example, if you right-click the top of a block, it would place a cube 3 studs up from the position of that block. Breaking was even easier, as all I had to do was just destroy the block on left-click. Still looks nothing like Minecraft, so I added some textures. But do you notice something perhaps wrong? Does it look a little bare? I think so. Let's fix that with trees. Much better. Although very buggy. Every tree isn't generated like trees should be, but instead they're just a group of blocks being placed. This means that they'll generate over a blank area, even if no chunk should be loaded. To be honest, I really don't want to fix this right now. It's good enough, and the trees make everything look so much better. Now this is the point this project started to go very, very bad. You see, up to this point, I've been doing what worked for the short term, while not really planning ahead for future issues. You know how I said earlier that you can't load or unload chunks? Well, implementing this is going to be a lot more complicated than I thought, at least for how I've been handling blocks thus far. If you've been paying close attention, you might know that I'm adding and removing blocks in the game's workspace directly. If I want to make a block, I just make it, and if I want to remove it, I just remove it. Those of you who've tried to make a chunk-based system before may already know the problem here. Let's say I want to make a system to automatically load chunks as I go. This isn't too hard and can be done with a function that looks a little bit like this. Now, say I want to load this chunk. Just call the load function and walk into it, right? Well, yes, and this is all good. However, let's remove a block, unload the chunk, then reload it. As you can see, our changes have been lost. At its core, this is a rather simple fix, but the way I've been writing the system so far implements a lot of difficulties. Because I'm just adding it to workspace, I have no way of keeping track of the blocks each chunk contains, which essentially means I can't save anything. Not to mention implement multiplayer, which is something I'd love to do in the future. With this, let's reapproach here. Instead of keeping everything on the client, I'm gonna move everything to the server. By keeping this separated, I can ensure that the data sent by the server is actually storable, and I'll need to do something like this anyway if I ever wanted to make multiplayer work. For this, I use Knit, because, I don't know, it seemed like the right thing to do. Anyways, here's the gist. On the server, there'll be a cache that holds all of the chunk data in the entire map. When you, the player, joins, it'll request whatever chunk it needs. The chunk is either retrieved from the map or is generated, and the requested chunks are then sent back. These blocks are added to the player's workspace locally, where they're placed at their specified position with their specified texture. Placing and breaking blocks will include a reference to the block to add or remove, modify the map, and send a remote event to all the players in a close proximity that whatever chunk had changed. Seems easy enough in theory, but boy did this take a while. For some ungodly reason, I tried to send the contents of the entire chunk through the network every time anything was modified. This was slow, buggy, painful, and overall just dumb. This system is so bad that if 2 players place 2 blocks at the same time, it would probably only be able to push one of the changes and the other would just get overwritten. It also means that every single change requires me to loop through the entire contents of that chunk to check for changes that need to be replicated. This was an easy fix though, which was just to replicate a single block at a time, but this is where I ran into a much bigger issue. To describe this, I'm going to have to go into a little bit of data structure concepts, so strap in. Time complexity is the amount of time it takes for an algorithm to complete in relevance to the length of its input. Let's say I have a table of values and I want to make a function that finds the term apple. To do this, I need to move through every item in the table and check its value. If the value is equal to apple, we return the index. If not, we just keep going. This algorithm has a time complexity of big O of n, n being the length of the list. This means that for any given input, the absolute worst case is that you'll have to search the entire list in order to find it. For a list of this size, this isn't really a problem. However, it'll immediately become a problem when we start scaling. If I have, say, 1 million items in this table, the performance of it will be noticeably slow. However, for the case of an unsorted table, big O of n is mathematically the most efficient way of doing a search this way. So how does this relate to my problem? Whenever a block broken event is sent over the network, the position of the block is sent. This means I can locate the position of the block by simply looping through every block, checking to see if the position matches, then destroying it locally if so. Well, if only it were that easy. Going back to time complexity, if I want to find the block by its position, I need to loop through every single block in the entire spaces of loaded chunks, check its position, and remove it if the position matched the target. If you have a render distance of 10 and there's only 1 block per vertical axis, this would mean that breaking a single block would require to loop through a minimum of 25,600 blocks. Yeah, this isn't gonna work. You can see here that every time a block is destroyed, it noticeably lags my game. This issue took me a long time to figure out. At one point I tried to do some sort of hash table and creating an ID of every single block in the game and referencing that. While that may have worked, the next thing I tried was a much larger change. You see, this entire time I've been working on essentially my own replication system for parts, but this is something that Roblox already provides via its workspace. All you need to do to replicate parts across the entire map to every single person is to add a part to workspace and it'll be there. I can even reference it by its actual instance since Roblox handles instances natively anyways. The system didn't take long to get up and running, and it pretty much solved all the issues with breaking blocks, as I could simply reference the block by its ID. Not only that, but because I'm using Roblox's networking, I don't have to worry about syncing issues across clients, since everything in Workspace is already synchronized. Or do I? Roblox already synchronizing everything seems like a good idea, but after trying to implement multiplayer, I noticed a rather significant issue. When playing it with a single player, everything worked great, and there's no problems. However, when adding another player, that story changes really quickly. Everything may seem fine when joining in, until you realize that every chunk is now loaded for every player on the server. To explain this problem, let me provide an example. When something is added to Workspace in Roblox, it is sent to every single connected client. This is great, as it allows for everyone on the server to synchronously see the same parts. However, what if you want to send a part to an individual player? Well, you can't. This means that there's no way for me to stop Roblox from automatically sending every block to every person in the server. And if you've ever had frame drops on Minecraft because your render distance was set too high, I bet you've picked out that this is a major problem, and thanks to the lack of flexibility provided by Roblox when interacting with Workspace, there isn't much of a good way around this. I tried adding the chunks to replicated storage and having the client move them in as needed, and this was better, but it still stored chunks in RAM, which saw my computer being brought to its knees even when I had very few chunks loaded. This means that, despite spending the better half of my day rewriting the entire replication system, back to the old one we go. Despite my initial challenges getting the system up and running, once I rolled back to the old version, getting everything working wasn't difficult at all. I still had the old code thanks to GitHub, so I was able to find a rather clever fix to the block breaking problem. One of the things I massively overlooked was Roblox's documentation. Roblox, for the sake of keeping things relatively simple, actually has a lot of really nice to use functions. Looking at the world root class, there's a lot of helpful functions, specifically get part bounds and box. This function returns a table of every part overlapping with a specified box. This means that all I have to do to get a part by its position is to call this function and I'm pretty much done. Now, I'm not entirely sold on this yet, and I don't think it'll scale perfect. You see, there are two types of functions that are accessible from Roblox's API, which are C functions and L functions. L functions are pretty normal, they're just regular functions written in Lua, which are then callable from your Lua program. C functions, on the other hand, are special because they are literally written in the C programming language, which is significantly faster than Lua. So while this seems much faster, it could be because the algorithm I'm using is simply written in a much faster language, which doesn't really solve my problem for when I need to scale much larger. I was going to end the video here and save the meat and potatoes for a part 2, but there's also one more thing I wanted to do. You see, in doing research for this project, I played a lot of Roblox clone games, and some of them have actually some really cool elements. Content creator 2NIX essentially already has a series on creating a Minecraft clone in Roblox, and he seems to be a bit ahead of me here. But there's one thing that always lacked in these types of clones, and that's the terrain generation, specifically in its variety. The reality is that creating good terrain generation is extremely difficult and computationally expensive. I wanted to create my own in-house solution that can provide cool terrain generation, but I didn't think that it was realistically possible within the bounds of my skill set. So instead of writing my own, I decided to use something that was already made. Even though this ended up taking up a significant portion of the overall time spent on the project, I'm not going to talk about this in too much detail and fear boring every single one of you. My first thought was to actually run a real Minecraft Bedrock server, but I was worried about the game getting taken down due to copyright issues. So far I've been pretty good about not stealing from Minecraft, except for the leaves of course, but this seemed like it was a bit too risky. Instead, I decided to go for Minetest. Minetest has a much less restrictive licensing agreement and also is a pretty good modding API. What this allows me to do is run a Minetest server that can communicate with the game on Roblox. By providing the means of communication between the mod and my Roblox game, I can just request the chunks from an actual Minetest server. This somewhat helps with computation, but it's mostly for providing means of high quality terrain generation without computing it locally within Roblox. This does unfortunately mean that the terrain generation is very slow now, but it does look quite nice, and this is a solvable issue. Because I didn't want to make textures for every block, everything I haven't made is just grass, which looks bad, but I'll save that for part 2. I do plan on mostly rewriting everything for the second part in this series, but don't worry, that doesn't mean I lost everything. So much of this project is conceptual that there isn't even that much code, all things considered. It's just determining the best way to do stuff that's been pretty tricky. I procrastinated so long in this video that there's been new APIs released as studio betas that I think we can do really cool things with. The most important two are the editable meshes and textures, which will allow for complete block culling. It also means I don't have to create a new instance for every block added, which is good considering that instances are very computationally expensive. If you want to see more on this, then yeah, subscribe, because I do plan on releasing a part 2, hopefully somewhat soon. I'm already working on part of the rewrite, but there isn't really much to show for. That's all I got. See ya.